Hello everyone, welcome to Saimedha KOTI Hyderabad. In this video, I would like to discuss class number 2 in the synchronous machine. The class is working of 3-phase induction motor. So in this topic, I will discuss short notes and practice question, concept through the question. This class is useful for Andhra Pradesh State Electricity Board AEE exam and also Telangana's genco, transco, discom AE exams. Initially, let's discuss short notes, and after that we will discuss about concept through the questions based on this topic. And short notes from the working of the 3-phase induction motor. So these short notes is also called short notes or key points or observations or possible questions from working of the 3-phase induction motors. 3-phase induction motor, first observation is 3-phase induction motor works on the principle of Faraday's laws of electromagnetic induction or mutual induction or transformer action. The 3-phase induction motor works on the principle of Faraday's laws of electromagnetic induction. Faraday's law of electromagnetic induction, or mutual induction or transformer action. Sometimes we have a question. The 3-phase induction motor works on the principle of Faraday's laws of electromagnetic induction or mutual induction or transformer action. And how do we calculate the synchronous speed in the 3-phase induction motor? Second observation is that is synchronous, the speed of the 3-phase induction motor, and synchronous speed is also called the speed of the rotating magnetic field. The synchronous speed is equal to ns is equal to 120 f by p. So f is a frequency and p is a number of the poles. And how to calculate the slip of the induction motor, slip of the 3-phase induction motor S, and it is slip in the per unit value. S is equal to ns minus n divided by ns here. So this is slip in per unit value, pu values. Sometimes slip in the percentage adutadu. So appudu ila calculate cheyala. The slip in percentage value is equal to ns minus n divided by ns multiplied by 100. So where ns is the synchronous speed, n is the rotor speed, divided by ns multiplied by 100. So this is the slip of the motor in percentage. And next possibility of the question, and speed of the motor. How do we calculate speed? The speed of a 3-phase induction motor. How to calculate speed of the 3-phase induction motor? N is equal to ns1 minus s. The speed of the 3-phase induction motor, n is equal to ns1 minus s1. And next one, rotor EMF. Okay, rotor EMF under running condition. So that is rotor EMF per phase. So under running condition. So it is denoted by E2. The E2 is equal to the S times of the E2, E20. So the E20 here at standstill. The at standstill condition, E2R is equal to the standstill conditions. Okay, and next rotor impedance per phase under running condition. Rotor impedance, rotor the impedance per phase, rotor impedance per phase under standstill condition. So how do we calculate rotor impedance per phase under standstill the condition and question? So that is Z20 is equal to R2 plus J the X2 values. Okay, R2 plus J. So magnitude of Z20, how do we calculate this magnitude? So that is equal to R2 square plus okay X2 square. So that is rotor impedance per phase under standstill condition. And one more formula, eighth one. So rotor impedance per phase under running conditions. So rotor the impedance per phase under running condition, running condition. So how do we calculate the rotor impedance per phase under running condition? So that is Z2R. So Z2R is equal to R2 plus J the SX2 terms. The X here S rotor impedance under running condition. And if you want to calculate the magnitude of this current, magnitude of this impedance under root of R2 okay plus the S R2 square plus SCX2 whole square. So rotor impedance per phase under running condition Z2R is equal to R2 plus J SX2 whole square SX2. And next one more possibility of the question from this concept, ninth one, and rotor current at standstill condition. Rotor current, the rotor current per phase the at standstill condition. So this rotor current at standstill condition the is equal to, so that is I2 0, and you can say that the E2 divided by, so this R2 under root of R2 square plus the X2 square. So this is the rotor current per phase at standstill condition. And ninth another possibility of the question is the rotor current per phase under running condition. The rotor current, okay, this rotor current per phase, so under running condition. How do we calculate rotor current per phase under running condition? So it is denoted by I2R. So this value is equal to the SE2 divided by under root of R2 square plus okay this SE2 0 or SE2. So under running condition R2 square plus the SX2 the whole square. So rotor current per phase under the running condition. And next possibility of the question, the 11th point is the rotor power factor under standstill condition. The rotor power factor under standstill condition. So this rotor power factor, the cos theta 0, so it is equal to R2 divided by under root of the R2, okay, this one is R2 square the plus the X2 square. This is rotor power factor under standstill condition. And one more possibility of the question, the rotor power factor under running conditions. How to calculate rotor the power factor under under running condition, the running conditions. And rotor power factor under the condition cos 2 theta are is equal to R2 divided by under root of the R2 square okay plus SX2 whole square. So this is another possibility of the question. Ee formula nunchi kuda question adige chances untayi, rotor power factor under the standstill condition. And next possibility of the question is okay 13th one, the 13th, so observations from the working of the 3-phase induction motor and speed of the stator rotating magnetic field And suppose before that one more question is rotor the frequency paina question adutadu. The how to calculate the rotor frequency. Rotor frequency Fr is equal to the slip times of the supply frequency. So where S is equal to the ns minus n divided by the ns. Rotor frequency ela calculate cheyala. ఇప్పుడు రోటార్ ఫ్రీక్వెన్సీ ఎట్ స్టాండ్ స్టిల్ అంటే ఎస్ వాల్యూ ఈజ్ ఈక్వల్ టు 1 అవుతుంది, ఎఫ్ఆర్ ఈజ్ ఈక్వల్ టు ఎఫ్. ఇది రోటార్ ఫ్రీక్వెన్సీ అండర్ ద రన్నింగ్ కండిషన్ అండి. సో రన్నింగ్ కండిషన్స్, అండర్ రన్నింగ్ కండిషన్ ఎఫ్ఆర్ ఈజ్ ఈక్వల్ టు స్లిప్ టైమ్స్ ఆఫ్ సప్లై ఫ్రీక్వెన్సీ. And next possibility of the question here, the frequency, suppose speed of the rotor stator rotating magnetic field with respect to the stator rotating, with respect to stator, the speed of, okay, very important one, speed of the stator rotating magnetic field, RMF is nothing but speed of the stator with respect to, okay, with respect to the stator. The speed of the field is always ns, speed of the stator is equal to 0, the relative speed is equal to ns minus the 0, so is equal to the ns. So like this you can calculate. And next to speed of, okay, this the speed of rotor, speed of the stator RMF, so with respect to rotor, so with respect to the rotor, so that is ns minus n, so ns minus n value. And next to speed of, okay, one more possibility of the question, the speed of the rotor RMF, so with respect to the, with respect to the stator, so with respect to the stator, rotor field is the ns and stator speed is equal to 0, and therefore ns minus 0 is equal to ns value. And next possibility of the question, speed of the rotor RMF, so with respect to the stator, with respect to rotor, so then it is equal to ns minus n. And one more possibility of the question, speed of the rotor RMF, so with respect to the stator RMF, so both fields are rotates at the synchronous speed, so relative speed is ns minus ns, that is equal to the 0. Speed of the rotor RMF, so with respect to the stator RMF is equal to n is equal to the 0. Another possibility of the question, the 19th one, thus here, speed of the rotor with respect to the rotor RMF, it is equal to n. So initially mentioned that rotor and rotor RMF, so the with respect, so speed of the rotor with respect to rotor RMF, so that n minus ns. And one more, speed of the rotor, so with respect to the stator RMF, it is also is equal to n minus the ns value. So this type of the question we can expect from this concept. So all these, so speed of the rotor RMF with respect to stator, speed of the stator RMF with respect to rotor, speed of the rotor RMF with respect to the stator RMF, okay, ఇలాంటి క్వశ్చన్స్ అన్ని కూడా ఈ వర్కింగ్ ఆఫ్ 3-phase ఇండక్షన్ మోటార్లో ఎక్కువ శాతం అడిగే అవకాశం ఉంటుంది. ఓకే, let us solve the question based on this concept, working of the 3-phase induction motor. Question 1 is a 3-phase 4-pole 50Hz induction motor at a speed of 1440 rpm. Statement 1 is its slip is 0.04, its rotor field rotates at 60 rpm with respect to rotor, its rotor field rotates at 60 rpm with respect to stator field, its rotor runs at a speed of 60 rpm with respect to the stator field, its rotor field rotates at a speed of 1500 rpm with respect to the stator. From these rotor correct statements are option 1 1 2 3 1 2 4 5, option 2 1 2 3 4 5, option is 1 is 1 2 5, and option 4 1 2 4. And first let us see the statement 1. So 3-phase 4-pole 58 induction motor runs at a speed of 1440 rpm per. And here given that let us calculate the synchronous speed. Ns is equal to the 120 f by p. So ns is equal to 120 f by p, and 120 50 hertz, number of poles is equal to 4. So that this one is equal to 1500 rpm. And slip of the motor, so given speed, rotor speed is equal to 1440 rpm. So now let us calculate the slip here. The slip of the motor is equal to ns minus n divided by ns, and 1500 minus 1440 divided by 1500 rpm, the equal to 0.04. So its slip is 0.04. So this is the correct statement. And next one, its rotor field rotates at 60 rpm with respect to the rotor. So now let us calculate speed of the rotor RMF, So with respect to the rotor, ns minus n. So 1500 minus 1440 rpm, the is equal to 60 rpm. So rotor field rotates at 60 rpm. So this is also correct statement. Rotor field rotates at 60 rpm with respect to the stator field. And third statement, speed of the rotor field. So this rotor field, so with respect to the stator, the ns minus 0, it is equal to 1500 rpm. So here speed of the rotor field with 60 rpm with respect to the stator, this is the wrong statement. Actually it is a 1500 rpm. Its rotor runs at a speed 60 rpm with respect to the stator field. And this is also okay. The third stage of its rotor runs at 60 rpm with respect to the stator field. So that means speed of the rotor field, stator field with respect to the speed of the stator field. So with respect to rotor, the is equal to ns minus the n. So it is nothing but 1500 minus 1440. So is equal to 60 rpm. So this is also correct statement. And its rotor field rotates at a speed of 1500 rpm with respect to the stator field. So that is the third question. The speed of the rotor field with respect to the stator is of 1500 rpm. This is also correct statement. So answer for this question, what are the correct statements here? 1, 2, 4, 5 statements are correct. Fourth statement, third statement is wrong. So option 1 is correct for this question. And next one, question number 2. A 3-phase 400 volts 6-pole 58 squirrel cage induction motor is running at a slip of 5%. The speed of the stator magnetic field with respect to rotor magnetic field, and speed of the rotor with respect to the stator magnetic field. Options 1, 0 minus 50 rpm, 0 950 rpm, 1000 rpm minus 50 rpm. So 1000 rpm comma 950 rpm. So first synchronous speed, let us calculate the synchronous speed. ns is equal to 120 f by p. So 120 50 hertz, number of poles is equal to 6 number of the poles. So this value is equal to 1000 rpm. Synchronous speed is equal to 1000. Now our question is speed of the stator RMF, stator rotating magnetic field with respect to the rotor rotating magnetic field. So speed of the stator RMF, so with respect to rotor RMF, so rotor, both fields rotates at the same speed. So ns minus ns is equal to the 0. And next second one, speed of rotor with respect to the stator rotating magnetic field. The speed of the rotor, with respect to stator rotating magnetic field. So it is equal to N minus Ns. The N relative speed we have to calculate, and this is equal to, so N minus Ns means 950 RPMs. Slip is mentioned here, slip is equal to C. And what about the speed? N is equal to Ns 1 minus S. Ns is a 1000, 1 minus 0.05. So it is equal to 950 RPM. Speed of the motor is equal to 950. So 950 minus 1000, so equal to minus 50 RPM. Minus is nothing but opposite direction. So option 1 is correct for this question. And next let us solve question number 3. A 4-pole induction motor supplied by the slightly unbalanced 3-phase 58 Stotors. It's rotating at 1440 RPM. The electrical frequency in edge of the induced negative sequence current in the rotor is option 1 100 Hz, option 2 98 Hz, option 2 52 Hz, and option 4 is 48 Hz. So this first let us calculate synchronous speed of the motor. Ns is equal to the 120 F by P. So this Ns value is equal to 120 F by P. 120, the 50 Hz frequency, number of poles was given 4, so equal to 1500 RPM. And let us calculate the slip. S is equal to S value and Ns minus N divided by Ns. So Ns is a 1500 minus 1440 RPM divided by 1500 equal to 0.04. Per the slip of the motors. This is the slip per the negative sequence current. Slip of the motor for negative sequence current. For negative, the sequence current is equal to, so that is 2 minus S. So that is 2. This is a forward slip SF, and this is also backward slip. So SB 2 minus SF. 2 minus 0.04, it is equal to 1.96. Now what about rotor frequency? Fr is equal to rotor frequency for negative sequence current. Rotor frequency for the negative sequence current. The rotor frequency for negative sequence current is equal to the 2 minus S multiplied by supply frequency. 1.96 multiplied by 1.96 multiplied by 50. So this value is equal to 98 Hz. So answer for this question, option 2 is correct for this question. So next let us solve the question number 4. A 3-phase slip ring induction motor has standstill rotor impedance per phase of 3 plus J 4 ohms per phase and rotor EMF of 100 volts per phase at standstill. The rotor current at standstill is option 1 25 amps, option 2 30 amps, and option 3 35 amps, and option 4 20 amps. So rotor current, okay, this rotor current per phase at standstill condition, the is equal to, so that is denoted by I2, the equal to, so E2 divided by under root of R2 the square plus, okay, X2 square. So this I2 is equal to E2 at standstill condition rotor EMF 100 volts divided by under root of the 3 square plus the 4 square. So 100, so divided by 3 square plus 4 square, that is under root of 9 plus 16. So 100 divided by, so root the 25. So this is equal to 100 the root 5 square. So this cancel, 100 divided by 5 equal to 20 amps. So answer for this question, option 4 is correct. And next let us solve question number 5. A 6-pole 50Hz wound rotor induction motor, when supplied at the rated voltage and frequency with a slip ring open circuited, the developed voltage of 100 volts between any two slip rings. If the rotor is driven by the external means at a speed of 1000 rpm in opposite direction to the stator field, the frequency of the voltage across the slip ring will be. So now the speed one is 0, 25 Hz, option 3 the 100 Hz, and option 4 is 200 Hz. Now let us calculate slip per opposite rotation. Slip is equal to ns minus per opposite rotation minus n divided by ns. Therefore ns is equal to, what is the value of ns here? The ns is equal to 120 f by p, speed of the rotating magnetic field. So 120 50 Hz, number of poles is equal to 6. So that is equal to 1000 rpm. Now let us calculate the slip of the motor. So 1000 minus 1000. So therefore minus 1000 divided by 1000. So by simplification, s is equal to 2000 divided by 1000, the equal to 2. So slip is equal to 2. Why this slip is more than, more than the 1? Because it is rotor rotates opposite direction to the stator rotating magnetic field. So now opposite direction, these are stator rotating, that's why n is minus. So slip is the 2. Therefore rotor frequency fr is equal to s times of the f. So 2 into 50 is equal to 100 Hz. So now this one is the rotor frequency fr is equal to the 100 Hz. So the speed frequency of the voltage across the slip rings. Sometimes ఇదే క్వశ్చన్ లో సో ఒకవేళ రోటార్ ఈఎంఎఫ్ అడిగే ఛాన్సెస్ ఉంటుంది. సో రోటార్ ఈఎంఎఫ్ E2 R is equal to the S times of the E2 0. So open circuit condition లో S ఎంత 2. So this value is equal to 100. So now this value is equal to 200 volts. ఇంకా దీనికి ఎక్స్టెన్షన్ అడగాలనుకుంటే క్వశ్చన్ ఎట్లా అడుగుతాడు? వోల్టేజ్ రోటార్ voltage across this E2 0 అనొచ్చు, దీని voltage across the slip rings, ఒక voltage across the two slip rings under running condition. The S into voltage across the slip ring in under standstill 2 into multiplied by 100 volts equal to 200 volts. సో ఈ విధంగా కూడా క్వశ్చన్ అడిగే ఛాన్సెస్ ఉంది. అండ్ నెక్స్ట్ పాసిబిలిటీ క్వశ్చన్స్ హియర్, a center zero ammeter connected in the rotor circuit. Center zero ammeter is connected in the rotor circuit of 6-pole 58 slip ring induction motor makes 45 complete oscillations in 1 minute. In RPM, the rotor speed and speed of the stator field with respect to the rotor R respectively. These are options for this question. And first one, let us calculate the synchronous speed. Ns is equal to 120 f by p. So 120 50 Hz, number of poles is equal to 6, okay, equal to the 1000 rpm. And rotor frequency fr is equal to, so fr, so we have fr is equal to number of the revolutions, okay, number of revolutions of the rotor per second. So now this is equal to the 45 divided by 60. So now this is equal to 3 by 4. So rotor frequency is equal to 3 by 4. And now we required, so this we know the rotor frequency, supply frequency also there. Now let us, we know rotor frequency fr is equal to the slip times of the supply frequency. So fr is equal to 3 by 4. So multi is equal to slip s is equal to the 50. So supply frequency is equal to 50 Hz. Now s is required, so that this value is equal to, okay, s value is the 3 divided by 4 into 50. So 4 into 50 values, and this value, so let us simplify now. So 0.015. So slip of the motor is equal to 0.015. So now let us calculate the speed here. The speed n is equal to ns, first question speed 1 minus s. Okay, ns is equal to 1000. The 1 minus, okay, this one is 1000. 1 minus 0.015 So 0.15. So by simplification, so equal to 985 RPM. Now one more possibility of the question, speed of the stator field with respect to the rotor. So speed of stator RMF, so with respect to the stator, with respect to the rotor, so is equal to ns minus n. So 1000 minus 985 rpm equal to 15 rpm. So this is speed of the stator RMF, so with respect to the rotor. So these are some questions based on this concept. So ilanti questions enno the video classes lo discuss cheyadam jarigindi practice question lo. So just sample point of ఏ విధంగా క్వశ్చన్ అడుగుతారు, డిఫరెంట్ మోడల్ ఆఫ్ ద క్వశ్చన్స్ తీసుకొని నేను చేసడం జరిగింది. సో ఇలాంటి కంటెంట్ సాయిమేధ కోటి హైదరాబాద్ స్పేస్ గేట్ ద్వారా మీకు అందించబడుతుంది. మరి ఈ కంటెంట్లో ఈ ఆన్లైన్ ప్రీ రికార్డెడ్ కోర్సులో ఉండే ద ఫీచర్స్ ఏంటంటే, మొదటగా టాపిక్ వైజ్ వీడియో క్లాసెస్ ఉంటాయి, తర్వాత ప్రీవియస్ గేట్ క్వశ్చన్స్ విత్ వీడియో సొల్యూషన్స్ ఉంటాయి, అండ్ నెక్స్ట్ ప్రీవియస్ ఈఎస్సి క్వశ్చన్స్ దానికి సొల్యూషన్ చేయడం జరిగింది. ప్రీవియస్ ద ఏపీపీఎస్సి క్వశ్చన్స్ కానీ టీఎస్పిఎస్సి క్వశ్చన్స్ కూడా వివరంగా సొల్యూషన్ చేయడం జరిగింది. అండ్ ప్రీవియస్ అదర్ స్టేట్ క్వశ్చన్స్, ఒక ఇలా మన స్టేట్లో జెన్కో ట్రాన్స్కో డిస్కన్స్ ఏ విధంగా ఉంటుందో, అండ్ ఇండియాలో ఉన్న అదర్ స్టేట్ ఎలక్ట్రిసిటీ బోర్డ్ ఎగ్జామ్స్ యొక్క ప్రీవియస్ ఇయర్ క్వశ్చన్స్ను కూడా కలెక్ట్ చేసి వాటికి వీడియో సొల్యూషన్స్ ప్రొవైడ్ చేయడం జరిగింది. అదేవిధంగా స్టాండర్డ్ టెక్స్ట్ బుక్స్ క్వశ్చన్స్, అంటే ప్రతి సబ్జెక్ట్కు ఒక స్టాండర్డ్ టెక్స్ట్ బుక్ క్వశ్చన్ టాపిక్ వైజ్గా స్టాండర్డ్ టెక్స్ట్ బుక్ క్వశ్చన్స్ కూడా డిస్కస్ చేయడం జరిగింది. సో వీటితో పాటు టాపిక్ వైజ్ ప్రాక్టీస్ సెల్ఫ్ టెస్ట్లు ఉంటాయి, టాపిక్ వైజ్ లైవ్ టెస్ట్ ఉంటాయి, టాపిక్ వైజ్ లైవ్ అండ్ గ్రాండ్ మాక్ టెస్ట్ కూడా ప్రొవైడ్ చేయడం జరుగుతుంది. సో ఇంత కంప్లీట్ కోర్స్ అనేది, ద కంటెంట్ను కూడా మీకు చాలా తక్కువ ప్రైస్లో స్పేస్ గేట్ ద్వారా చాలా తక్కువ ప్రైస్లో ఆన్లైన్ కోర్స్ ఎంత ఉంటుందంటే 9000 రూపీస్ ఉంటుంది. మరి ఒకవేళ మీరు ఆన్లైన్ ప్లస్ ఆఫ్లైన్ రెండింటికి రావాలనుకున్నప్పుడు దాని యొక్క కోర్స్ ప్రైస్ ఎంత 27,000 రూపీస్ ఉంటుంది. సో ఈ కంప్లీట్ కంటెంట్ను మీకు స్పేస్ గేట్ ద్వారా మీకు అందించడం జరుగుతుంది. సో ఈ కోర్స్ గురించి ఇంకా మీకు ఏమైనా డౌట్స్ ఉంటే ఇక్కడ కనిపిస్తున్న నెంబర్స్ కాల్ చేయండి. 9848692598, సో 9849713451. సో ఇది శశికాంత్ సార్ నెంబర్. సో మీరు ఈ నెంబర్ కాల్ చేస్తే సార్ వివరంగా మీకు ఎక్స్ప్లెయిన్ చేయడం జరుగుతుంది. సో కోర్సు గురించి కావచ్చు, సబ్జెక్ట్ గురించి కావచ్చు, తర్వాత ప్రిపరేషన్ స్ట్రాటజీ గురించి కావచ్చు, ఏదైనా మీరు సార్ కాల్ చేయొచ్చు. ఏ టైంలో అయినా కాల్ చేసి సార్ని అడగండి, సార్ మీకు చాలా వివరంగా ఎక్స్ప్లెయిన్ చేస్తాడు. సో దిస్ వాజ్ డిస్కషన్ అబౌట్ క్లాస్ నెంబర్ 2 ఇన్ ద ఇండక్షన్ మిషన్. I hope you got it. Thank you very much.